Hi there, I'm Justin.
And I'm Cameron.
And we're here at Upminster Windmill to show you the digital sensor technology we've been building over the last few months to keep a virtual eye on the windmill 24 hours a day. And we're really excited to say it's been shortlisted for the BAFM Impact Award 2021.
So in addition to regular maintenance, these technologies allow us to keep an extra eye on the mill, whatever the weather conditions, and make sure that it's functioning properly and that the mill is staying safe.
And it also helps everyone understand more about the challenges of harnessing wind power and the mechanics of this marvellous machine.
Brilliant. So we're going to have a look at some of the technologies. So here we are at the back of the cap at Upminster Windmill, and you can see we're right by the fantail here. And the job of the fantail is to turn the cap to always face into the wind, whichever direction it's coming from. So you can see here the fantail has just caught a gust of wind, and it's bringing the cap round through a series of gears down to the rack on the top of the smock tower. It's starting to wind the cap round to face into that wind, whichever direction it's coming from. Now the cap and sails are designed to have the wind blowing onto them from the front. That's the way that they're designed to work from. And so it's really important that we make sure that whenever the wind changes directions, that it always turns to face that way. There is always the risk of a tailwinding, which is when the wind drops and it picks up from about 180 degrees around, and the fantail is usually unable to detect that change. And so we need to make sure that we're aware of what the cap's doing and able to monitor it, and if needed, intervene to make sure that the cap is turning to face into the wind as it should do.
So as soon as the cap was replaced in December 2020, we installed a webcam so that we could keep a watchful eye on the mill day and night, especially at times of strong or changing wind conditions. You can see from this time-lapse footage how the cap turns, sometimes with just minor adjustments to keep itself aligned to the wind, but sometimes with significant turns, as fast as 180 degrees in less than half an hour. The webcam has proven really popular, but it was clear there would be a lot of value in going a step further and equipping the mill with sensors to monitor the movement of the cap. Not only would we have a means of alerting us straight away if anything was amiss, we'd also collect a wealth of data about how the mill behaves in different wind conditions. So our first challenge with the digital sensor technology was to get a digital compass up here in the cap so we knew which way it was facing at any given time. The biggest challenge in doing this was to get a sensor that could run for a decent period of time on a small battery, that could transmit data wirelessly over a useful distance and could be installed discreetly in the fabric of the building. So here we are, Mark 1 of our digital device. It's tucked away here at the edge of the cap. It's a device we built ourselves. It's made with an Arduino, a digital magnetometer and a LoRaWAN radio, and it takes a compass bearing every couple of minutes and transmits that wirelessly to a LoRaWAN network. LoRaWAN's a radio technology designed for sending really small amounts of data over quite long distances. So the signals from this actually get picked up sometimes several miles away on public LoRaWAN gateways that are operated by the Things network. We've got our own software hosted in Microsoft Azure, where we store and manage the data, a website to view it, and a mechanism to send alerts if the system notices anything untoward. And then up here on the roof of the visitor centre, we've got a weather station which gives us a live view of the wind direction and speed. And here's the end result, where we present the data from both the compass and the weather station in a single diagrammatic view. In this footage, everything's as it should be, with a light northwesterly wind.
So following interest from other mills, we've been able to locate a commercially available magnetometer, and as you can see here on this wind map, we are able to monitor some mills that we've installed these at for our initial trial. So you can see that we've got Upminster, Stock, Wilton and Fulwell mills all being monitored by these devices, and they're all, as you can see, facing into the wind. It's quite dramatic wind at the moment, but you can see that all of the caps are facing into the wind as they should do.
And you can click on any of the mills to see the live data from the sensors. In the case of Upminster here, we've got the the cap, the fantail, and the sail sensor together with the weather forecast for the next 72 hours, as well as analysis in the form of a windrows and graphs and analysis showing how the cap has moved over recent days. But there's still more to see here at Upminster. While we were developing the compasses, we had a few ideas about other things it might be useful to measure too.
We've put a device so that we can measure the speed of the sails and how quickly they are rotating, and we've also put a sensor on the fan gearing so that we can measure how much the fan has turned, and in turn how much the cap has revolved on top of the smock.
Cool, should we go and take a look then?
Sounds good. So we're back here in the cap now, and you can see here we've got the wind shaft which is supporting the sails out the front of the cap, and onto the wind shaft we've got the brake wheel, which is this large wheel here. And what we've been able to do is to monitor and record the speed of the sails as they rotate. We've put a very small discrete magnet on the rim of the brake wheel, and we've got a reed switch down here which is triggered every single time the magnet passes, and very, very similar to a bicycle computer. And here we're able to monitor live the speed of the sails, how many revolutions per minute they're going at. And here at the back of the cap we can see the brake lever, which releases the brake band that stops the sails from turning, and we've got a sensor here so that we can see whether the brake is on or off.
Measuring the fantail movement was a bit more tricky as it turns both ways, but we've managed to do that using a bidirectional tachometer built with 3 reed switches, which measures which way it's turning as well as how fast it's going. All of these things are wired into another Arduino which is tucked away at the edge of the cap, and as with the fantail sensor, the data is transmitted in real time via LoRaWAN to our website through the Things network. So wherever you are in the world, you can see the live data from our sensors on the website smartmolen.com. And when the mill opens to the public in 2022, you'll be able to explore data and analysis from our sensors on the interactive screens here in the visitor centre, showcased together with the digital archiving and modelling projects undertaken by the Friends in the last few years. Cool, so should we give it a run then?
Yeah, we'll take the brake off and strike the shutters. Super. Then we pop a weight on to make sure that they stay closed. Brilliant. And as we can see, the sails are starting to pick up some speed now. And as they do, we're monitoring and recording every movement to help us keep the windmill in best condition for generations to come.
With 21st century Internet of Things technology to complement this 19th century mechanical marvel.